Hello. Good evening, everyone. Good evening, and this is Japi, and welcome to another episode of Differential Equation. Okay, so more examples actually for today. We're gonna have three topics: elimination of arbitrary constant, families of curve, separation of variable. Okay, so this will be a long video, but I'm planning to make this into three parts or to two parts, depending on how much time we're gonna use to solve for this problem. But yeah, let's get started. We have a lot of problems today and a lot more lessons to teach. Okay, so for example, number one, elimination of arbitrary constants. We have y is equal to c1 plus c2 e to the negative 4x. Okay? Arbitrary constants are constants with no fixed value. We eliminate them or we take them out to get the differential equation. Okay? The arbitrary constants are contained in your general solution, and in order to get the differential equation, we differentiate your general solution depending on how many arbitrary constants you have. So you have two C1 and C2 are two arbitrary constants. We differentiate them twice. Differentiate C1 as constant plus negative 4 C2 e to the negative 4x. Y double prime is equal to positive 16 C2 e to the negative 4x. Okay. So in this case, C2 is not eliminated because C2 is with e to the negative 4x. So in order to do that, we might add, okay, y double prime with y prime. We add it multiplied to 4y prime. So the 16 C2 e to the negative 4x of y double prime gets added to the 4 times y prime, negative 4 C2 e to the negative 4x. And that will become positive 16 minus 16, right? C2 e to the negative 4x, and that will become 0. Your arbitrary constants are now eliminated. Thus, this is your differential equation, and this is your answer. Okay, for number 1. Hey, let's continue for number 2. We're on a roll. We already solved number 1. That's pretty good. Yeah, let's go. That's very fast. Okay, let's do number 2. Okay. It's very excited. Yeah, it's very exciting. We already solved number 1. It's very easy. Okay, but I think number 2 is a little harder. Okay, so c1 x squared plus c2 e to the 2x. Or some examples or some instances, when we differentiate twice because there's two constant, 2x c1 plus c2 2 e to the 2x. Again, why I'm coughing, 2c1 plus 4c2 e to the 2x. Okay, so in this case, we didn't get to eliminate c1 and c2. We already differentiated twice, but we didn't get to eliminate c1 and c2. So in order to do that, we can use elimination method. Okay, I'm just gonna use elimination method. So for example, we got 3 equations here. I'm gonna just eliminate c1 first. So y double prime, okay, minus y prime times 2. Okay. Oh wait, okay, I said c1, but I'm gonna eliminate c2. Okay, so c1 2, that's for y double prime, minus 4x, that's for y prime because we multiplied y prime by 2, plus 4 c2 e to the 2x minus 4 c2 e to the 2x. Remember, we multiplied y prime twice. Okay, so this will become 0. We have our fourth equation now. Okay, for our third equation, I think we're gonna use y prime minus 2y. Okay, for y prime we got 2x c1 plus 2c2 e to the 2x, and y is negative 2c1x squared minus 2c2 e to the 2x. Okay, so we will have now y prime minus 2y is equal to c1 2x minus 2x squared. Okay, that's our fifth equation. Okay, if we divide fifth with fourth, okay, if we divide fifth with fourth, our fourth is 2 minus 4x. Okay, we can cancel c1 and we just simplify our equation. Y prime minus 2y 1 minus 2x. I'm gonna eliminate 2 from both of them, right? Then y double prime minus 2y x minus x squared. Okay, y prime. Okay, don't forget that it is y prime. Okay, so this will become negative 2y multiplied to 1 minus 2x. Y double prime x minus x squared. Okay, but this will become positive. We're gonna put everything on the right. Okay, we're gonna put everything on the right. For y prime, let's multiply this y prime on the right. Let me do this clean. I'm too excited. Okay, let me do this clean. Okay, we're gonna put everything on the right first. I'm gonna start with this one. So y double prime x minus x squared. Okay, for y prime minus y prime 2x minus x squared. Okay, then we're gonna put the left side on the right too. Minus y prime 1 minus 2x. Okay, plus 2y 1 minus 2x plus, okay, so we can simplify y prime. Okay, y double prime x minus x squared. For y prime, positive 2x, negative 2x, that's gonna be cancelled. Okay, negative y prime 1 minus x squared plus 2y 1 minus 2x, okay, is equal to 0. This is now our final answer. Okay, is that 1 minus x squared 2x? I think that's 1 minus 2x squared. Alright, because that's we multiplied this by 2. Alright, so this is supposed to be 2. Okay, double check your answer, double check your coefficients. Have you multiplied right? Double check your signs. Maybe we have the wrong sign, so I'm gonna double check if my signs negative on the outside. I moved the 2 inside, so we should have 1 minus 2x squared. Okay, I think our answer is correct. This is now our final answer and our differential equation. Okay, hey, we're in a row. Hey, let's move on to circles with tangent whose tangent to x-axis. Okay, so this is a family of curve problem. Okay, this is a family of curves problem, and family of curves talks about curves or equations of curves. Okay, and when we talk about equation of curves, for example, a circle is a curve. X minus h squared plus y minus k squared is equal to r squared. That's a normal general solution for circle, but it says it's tangent to x-axis, so your circle can be like this one, like this one, like this one. And when you say your tangent to x-axis, your k and your r is equal. Okay, for example, if this is your circle, meaning your y value should be equal to your radius, because your circle is always tangent to x-axis. Okay, meaning your equation will be x minus h squared plus y minus k squared is equal to k squared. Okay, so in this case we have two arbitrary constant. Okay, this is our initial condition. We have two arbitrary constant, h and k, or h and r. We are going to distribute, or we are going to eliminate the arbitrary constant, differentiate the arbitrary constant twice, or differentiate the equation twice. Okay, so this will become 2x minus h plus 2y minus k y prime is equal to 0. Okay, divide both sides by 2. This become x minus h, okay, plus y minus k y prime, okay, is equal to 0. Okay, differentiate again. This will become 1 plus, okay, differentiate twice, right? So there are two variables here. I'm gonna differentiate it once. Y prime, right? Then y minus k plus y double prime is equal to 0. So we have y minus k y double prime is equal to negative 1 plus y prime squared. Okay, so if we divide both sides by y double prime, okay, so that will be y minus k is equal to negative 1 plus y prime squared over y double prime. That's negative. Okay, that's y minus k. Okay, and k, y plus 1 plus y prime squared over y double prime is equal to k. Basically, I just transpose the terms. Okay, that's our k. Okay, and if we substitute them, oh wait, let's get x minus h. Okay, x minus h is equal to negative y minus k, okay, y prime. Okay, that's x minus h. Okay, now we can substitute them in the general equation. This one, right? This is our general equation. We can substitute all of them. X minus h is y minus k y prime. X minus h y minus k y prime negative squared plus y minus k squared is equal to, okay, k is y plus 1 plus y double prime, oh, not double prime but y prime squared over y double prime. This one, that is k. Okay, we, for the right side, we just put the y double prime on the y double prime plus y plus 1 plus y prime squared over y double prime. Oh wait, that's squared too, because k squared on the right side, right? That's squared. This is double prime. Okay, for this one, we squared the insides. This will become y minus k squared negative squared y prime squared plus y minus k squared. And y minus k, that's a multiple, so that will become y minus k squared multiplied to y prime squared plus 1. Because you have multiple, you have a common factor on the two terms. Okay, is equal to, I'm gonna move this downward. Plus, I think we're writing on a inclined plane. Why am I writing on an inclined plane? I'm gonna rewrite this. Okay, your equation will become y minus k squared multiplied to y prime squared plus 1 is equal to y double prime plus 1 as y prime squared over y double prime squared. Okay? And y